Okay, so we are into the last section that we're going to do for this next quiz, so this is the last portion, so 2-1 through 2-4. The reviews are already up on Canvas. The solutions to last night's homework are actually under the announcements because I was worried with handing back your quiz today that we may not get to everything that we need to. So if you have questions about your homework, no worries, I posted the solutions under the announcements. So you've got your homework tonight, you've got the reviews over the weekend. We're going to go over the reviews on Monday, but let's hit chapter 2-4 now. Using postulates and diagrams. Okay, so we've got these postulates, and these postulates, remember that we said that these are these things that they are accepted to be true that we are going to do. Now, please, this is the number one question I get asked in this section, and I always say it, but then people didn't hear it. I am going to expect you to know every single postulate that we do today. However, what I don't need you to know is, I don't need you to know which one is postulate 5. I don't need you to know which one is postulate 6, postulate 7, postulate 8. I just need you to know what they mean. And that's what we're going to talk about here. So I don't care which one is number 5 and which one is number 6 and which one is number 7 and which one is number 8. Those aren't even real things. That is just how the book names them, that in the book that goes with this, if you were to tie it back to there and you were like, wait, what was that one that was postulate 5? Then they would call it postulate 5, so it's got some sort of order that they give it to you. So please understand, I don't care about those postulate numbers there, but I do care about what it means. And it says, the first postulate we're going to talk about says, through any 2 points, there is exactly one line. It just means that if you pick any 2 points in the world, I don't care how you do them, there's only one line you could draw. That, if I gave you 2 points, there's only one line that would go through both of them. You can't draw like 50 different lines that go through both of those points. If it only went through 1 point, you could do a lot of lines, but through 2 points, that's very difficult. So you are responsible to know these postulates because I might give you something that says, through any 2 points, there is, and then maybe just leave this blank here. It's like that. So it says, there is, and then you have to fill in the blank. So you would need to know that there is exactly one line. Not just one line, exactly one line. No more, no less. A line contains at least 2 points. So to actually make a line, one of the things that we're going to need is 2 points. Otherwise, we don't know where that line would go. It needs like some sort of definition. Where does this line connect to? When you start drawing a line, you need a place to connect it to. So a line contains at least 2 points. It can be more, but it can't be less than 2. If 2 lines intersect, then their intersection is exactly 1 point. By the way, these are the type of questions I have noticed that for some reason this year we are having a lot of difficulty with. Most of the points that have been missed are on questions just like this. If 2 lines intersect, well look, there's a picture. Draw a picture if you need to. 2 lines are intersecting. Their intersection is exactly 1 point. It's not a plane. There's not another line. It's exactly 1 point. And through any 3 non-collinear points, so the 3 points cannot be on the same line. So like A, B, and C here. A, B, and C right there are non-collinear points because while 2 of them may be on the line, all 3 of them together are not on the same line. There's exactly one plane. There'd be one plane that I could wrap around them, like a sandbox drawn around them. Like any 3 points I can put on a plane, any 3. Now it may not be the plane that's shown there, but I can put a plane around there. Just like I said that the one about the line being on a plane, that all lines can be on a plane. Okay, so any 3 non-collinear points, there is exactly one plane. That is how we make a plane, by using 3 non-collinear points. All right, more postulates. So you can see there's 3 more here. If you can understand this, that like if you're not seeing it already, there's the 2-1 through 2-3, then there's all these postulates. Again, don't say postulate 9, postulate 10. I won't even give you credit for those numbers. Those numbers are just a reference to, hey, remember, like that way I don't even have to keep repeating the whole thing. Like if I was like, hey, remember in your notes that postulate 9, the one that said, and then you're like, oh yeah, postulate 9, that was like, you don't actually need to know the number. I don't care whether you know the numbers or not. What I do care is you need to know things like a plane contains at least 3 non-collinear points. That's how we define a plane. It needs at least 3 non-collinear points. Yes, ma'am?
Since we don't have the official names for these postulates, would we get a question like, what does this thing mean?
And you're going to see this in the homework. You are most likely going to see this as a word is missing from the sentence, and you have to fill it in. Like, oh, I saw that before. What's the word that's missing here? Or I am going to show you a diagram, and you have to match it up with one of these postulates. Like, I'll show you a diagram of something, and you'll be like, oh, that's just like postulate 10 that says... Now, you don't need the postulate 10 part, but see how quickly it is to refer back to as opposed to not saying the whole thing? If 2 points are in a plane, then the line that contains them is in the plane. So watch this. If I have a plane, I'm just going to draw a plane here. And if there are 2 points that are in that plane, I think those 2 points are in that plane. There's A, there's B. Well, then it must be true that the line that contains them, the line that goes through that must also be in the plane. There's no way that couldn't happen. If the points are in the plane, the line that connects those points would also be in the plane. And this was the devastating one when it came to the test. This was probably the number 1 question that got people. If 2 planes intersect. So remember, 2 planes are like 2 flat pieces of paper, except for they go on forever. When 2 planes intersect, let's see if I can draw that here. We've got a plane. You know what? I'm just going to draw this as a cube. Not a cube. This is more of a rectangular prism there. All right, so there's 2 planes. If 2 planes intersect, then their intersection is a line. Let me tell you right now, like, more people miss this than anything else. And so I'm going to look at this top plane here. There's a plane. And let's look at another plane and see what happens when they intersect. The other one I want to look at is this one over here. How would you describe the intersection of those 2 planes? Colette. Line AB. So here would be the correct answer. What would not be the correct answer is this. That is a line segment. That does not continue going on.
What if the intersection would
be BH? No, we're talking about 2 flat things. So like when you say a point, definitely not. So look, let me bring this notebook together with this paper here. When I pull them together here, if you notice where they come together is a whole line. Look at that space in between them right before they touch. That is a whole line there. And you might be like, well, wait, that's a line segment. That's because I can't make paper go on forever, whereas planes do go on forever. Yes, ma'am?
The red is like the top part, right?
Yeah, it's just the red kind of disappeared there when I drew the blue. So like, I could call that, like that top plane, like I could call it ABC because that's 3 of its points, like A, B, C. And now I know that the one we must be talking about is right there. So what I do is I always kind of color them in as soon as I know what we're talking about. I just made this one up, but there's that top plane there. It's the top, it's the lid of this box, if you will. Number 1 miss. Now think about it. If it was on your last quiz, if it was on your last test, and you're seeing it again here, and there's a 3rd time where you get this wrong, then you are just not trying this one because it's like the 3rd time we've seen this here. If you're not getting this one right, that's a problem. All right, then we get to theorems. So those are all postulates, and postulates are just like, hey, you can believe them. You don't need to sit there and prove them. So a theorem is a statement that has to be proven. We're going to need a little more backup. So if you're saying that this theorem applies to something here, I need a little more proof that this is a situation that it matches here. So theorems can be applied to certain situations, but we need to make sure that we have the right situation to apply it for, and that's what we're going to look for. So, one of the things that we've got, and this came up in one of the homeworks, and so one of the symbols that people asked about, now you learned this a long time ago in kind of elementary school, but maybe you haven't addressed it since then. There's a symbol that looks like an upside down T. This is very important if you don't get this. When we use this symbol, it means that two things are perpendicular. And when we say perpendicular, that means they form a 90-degree angle. Just in case you haven't seen that in a while, when two things are perpendicular, it's not like being parallel. It's almost the exact opposite of being parallel. They definitely run into each other, and they run into each other at a 90-degree angle. So if a line is perpendicular to a plane, notice that line T. That's the one in the middle going straight down. It's like somebody has jabbed a pencil right through this paper there. A line is perpendicular to a plane if and only if, where have we seen those words before? Even if you don't know just give me something. A biconditional statement. Now remember, this is when we use those words in geometry, if and only if, this means that this is true backwards and forwards. Like we can reverse it and it's going to be true. It says a line is perpendicular to a plane if and only if. I'm going to underline that just because that's cool that we have seen that before and we know what that means. The line intersects the plane in a point and is perpendicular to every other line in the plane that intersects it at that point. What that means in English is that when we jab that line through the pencil, through the paper there, a line is perpendicular to a plane if and only if the line intersects the plane in a point and it's perpendicular to every line on that plane. So no matter which line you drew across the plane here, we would have 90-degree angles that the line going up and down makes, that's a horrible line, that this line makes, and all the other lines. So imagine it like this. If you need to see it in the real world, so like look back here for a minute. I'm going to take this notebook. Notice I'm holding it nice and flat and horizontal, and then I'm taking my stylus and I'm going to push it from the top right into the middle of the paper. It basically, now I can't say I'm exact, but I'm trying to make it as exact as possible. It makes a 90-degree angle with the paper. Well, any single line you were to draw on this paper, if you were to come over here and draw a straight line on it, and this were going and touching that line, it would definitely be at a 90-degree angle for it. Because, right, any line you draw on here would be flat and on the paper, just like the paper is. So if I'm perpendicular to the paper and your line is on the paper, then it must also be perpendicular. So it forms a 90-degree angle too. So when we look at it, we go, oh, all of those are 90-degree angles. This is perpendicular to all of those. All right. Now, you might have to flip back here. So here is kind of the things that you might see on a quiz, on a test. You might see on homework. You definitely wouldn't see it on those apps games that you are playing right now. So you might want to close those up. If you see something like this, what we're doing is we're going to interpret this picture. We're going to try to turn it into words. So like if this, whatever this is, then this. Now that is going to match up with one of those postulates, and we need to figure out which one that matches. Again, if you're not there yet, start flipping back and go, wait, which postulate is that? Yes, ma'am. Amber?
Okay.
Yep.
If two lines intersect, then their intersection is exactly 1 point.
Good, look at that. If two lines intersect, then their intersection is exactly 1 point. Now, can you, honestly, I say the thing about you don't need to know the number, but for this case, can we just use the number so it refers back to it? Again, you don't need to know the number, but just so I don't have to write all that, what number was that? Postulate 7?
Yeah.
Okay, again, the numbers aren't important, but I'm doing this so I don't have to write the whole thing out. Now, you will be responsible for writing out. I don't want the numbers from you, but I'm trying to keep your notes down a little bit so that I can just go postulate 7. Let me go back and see which one that is. Colette.
Could you paraphrase like the postulate?
Into what? Tell me how you would paraphrase it.
When I was gonna, so like when I wanted to enter it, I was gonna say when two lines intersect, they intersect at 1 point.
I think what you're doing is the best thing is that, so she's taking in her mind, and what she's doing is she's just condensing it down to the actual base meaning. She's like, two lines intersect, where they intersect is a point. That is great. Just understand that if I were to give you this sentence and leave a word out, you need to be able to translate it back and go, which word is missing there? So that's fine, because you've got the meaning of it, and that's the most important. But what also is important, that if I gave you like my version of this, like just like you saw in the earlier one, and took something out, you'll have to be like, okay, wait, which word is missing there? Exactly 1 point. All right, so let's look at the next one then. Let's do the next one. Yes, sir.
Two planes intersect and their intersection is a line.
Perfect. And will you help me out that which postulate that is? I honestly don't know.
11.
Postulate 11? Okay. I'm so serious that I don't know these, and I think it's so very not important that you know the numbers. The numbers are worthless, but I need you to be able to go, wait, which postulate was that? Which one does that match? And again, on your homework, on your quiz, on your test, putting postulate and then a number is not okay. I need you to use the words because these postulate numbers will not help you when we get to the proofs. What will help you are the words. When you know the words, you are golden. And if you think about it, I didn't need that number. I just said, well, look, two lines are intersecting and they intersect at a point. That's the basic meaning you got to get. Two planes are intersecting, and when they intersect at a line. That's really what you need to take away from it. That's not so hard. You can actually see that in the... All right. So I don't know what postulate 9 and postulate 10, or I don't know if those are the two. Actually, I do because we just said we said postulate 7. But so go back and take a look at postulate 9 and look at postulate 10. And then we're going to look for examples of those two postulates that are happening in this diagram. So take a look, and then you help me out. Somebody tell me, just even if you're not sure, tell me what postulate 9 says. Even if you just read it for me. Yes, ma'am.
The plane that contains at least 3 collinear points. Non-collinear. Non-collinear.
Okay, so let's find an example in this picture of a plane that contains 3 non-collinear points. Yes, sir? B, A, and C. B, A, and C are 3 non-collinear points. So here's what I'm going to do. I'm just going to write for postulate 9, just so you know which one I'm talking about here. B, A, and C are 3 non-collinear points and I'm going to say that they are on plane P. So notice in that lower left-hand corner they have that P. So I'm just going to make it easy to understand and say it's on that plane. So help me out now. Let's talk about postulate 10. What does postulate 10 say? You don't even need to raise your hand. Just somebody read it for me.
If 2 points are in a plane, then the line that contains them is in that plane.
Okay, so if 2 points are in a plane, the line that contains them is also in the plane. Where could we see an example of that? Yes, ma'am?
Line AB.
Okay, line AB. So notice, let's start by talking about the points. We've got points A and B are in plane what? Which plane are they in? P. They're in plane P. Now, I'm going to use a mathematical symbol here. If you've never seen this before, I'm just going to introduce something. It's not scary. It just means therefore. So here's what it means therefore. In math, those 3 little dots, that means therefore. We just kind of like to abbreviate stuff, and so we say therefore. Those 2 points are in that plane. Therefore, line AB is also in plane P. Notice there a little bit of abbreviation, but actually everything is represented there. The points A and B are in plane P. Therefore, the line AB must also be in plane P. If the points were in there, the line that connects them is also in that plane. Yes, ma'am?
On the homework, I think there was a question and there was a symbol where it was like an upside down T.
The one that we just drew two things ago?
Oh, okay.
Yep. It would look like this, and it meant perpendicular. That symbol means perpendicular. It means they form 90-degree angles. You're going to see it so much. You will see it now. There's also a symbol for parallel too, but which we haven't started yet. But this one is probably one you should know more often. When you see that, it means 2 things are perpendicular. So they definitely form 90-degree angles. If I use that symbol, they definitely form 90-degree angles. All right, so which of the following statements cannot be assumed from the diagram? So we're going to look. we'll just let's say true or false by going through these, or we can cross them out if they're not true. So let's look at A, B, and F. They're saying that A, B, and F are collinear. What does collinear mean? On the same line. Can we look at this picture and determine whether A, B, and F are on the same line? Yes. Are they? They sure are. They even drew a line through it. There's a line going through all 3 points, the same exact line. These are definitely collinear. So I'm just going to put a little check mark there. That one's good. E, B, and D are collinear. Can we assume that? No. While they may certainly look, I feel like maybe, like looking at EBD, that they might be, but I can't assume that. If they had drawn the line that connects them and it was a straight line, we'd be okay. But there's nothing connecting EB and D. For all I know, it might go like this. It might be like it going straight, and then like my line to do that might require a little bit of a curve. I cannot be assured that my line is straight there. So I cannot assume that. I shouldn't be drawing lines in there. By looking at that, I cannot assume that. So I'm just going to go ahead and put a little red X because I go, not that one. Line segment AB, that's this one right here, is perpendicular to plane S. How do we know that?
Because it has the little, the line it's talking about has the red square.
It's got this right here. It's definitely perpendicular to plane S. Now we have to be careful because I could easily trick you and say plane T. Like I could say plane T because I know people would go for it without, they're like, oh yeah, it's perpendicular to plane T. But like, wait. Plane T is not that red one. So that one is definitely true. CD, so that's line segment CD, that's this one right here, is perpendicular to plane T. Can we assume that one? Right, there's nothing there showing it's 90 degrees. Now, if you're like, but that goes through there. Sure, it might go through there at an angle, like a weird angle. Like it could be like going diagonally through the paper. So we cannot assume that one. There's nothing there that shows us that one is 90 degrees. Okay, last but not least on this one, we've got line AF. That's that whole one right here. Here's line AF. All of this intersects BC. Here is BC right here. It intersects B. Let me pick a different color. Did they say line segment? No, line BC. Those two things intersect at point B. Can we assume that? Yes, we see them intersecting at point B. There's even a point right there, and both lines are going through it. That one we can also assume. Because they're showing us that. That's why we can assume it. I can see that. I didn't have to add any information in to make that happen. That's already shown there. Okay, so it says name a pair of supplementary angles and a pair of vertical angles. Supplementary angles, what's true about supplementary angles? They equal 180. Okay, so we just need a pair, which is just one pair. We can name more, but really, I always say this. I actually have people who kind of tried to go above and beyond on their test. And unfortunately, when they went above and beyond, they listed things that were not correct and ended up losing points for it. Had they stopped earlier, they would have been fine. Name a pair of supplementary angles and a pair of vertical angles in the diagram. So let's name a pair of supplementary angles. Yes, sir?
PWQ and TWE.
Okay, PWQ, this one?
Yep.
So are you talking about this angle right here or the one in the bottom?
The one on the bottom.
So I'm a little bit thrown off here because remember a pair should be a set of two angles that equal 180, and you've already given me one angle that equals 180. So remember, two angles their sum will be 180. Try it again. So give me another set if that's not it.
PW and WQ.
So PW is just this line segment. I need a little more. PW what? So the first time you gave me PWQ, you gave me an angle at first. Don't worry, you're close. You're real close. The first time you gave me PWQ, which was an angle, And then you kind of shortened it, but you didn't give me an angle there, you just gave me the line segment. I need another letter to connect it to. And to be honest, whatever letter you pick, as long as you don't pick Q here, is going to be fine, but it's going to change what our second answer is. Give me any other letter. PW what?
T.
PWT. So here is your first angle. That's the first one you're giving me. That's the angle we're talking about. If that, and let me just do that, angle PWT. Notice it was fine. He gave me that one. And then if that is your first angle, then what is the other angle?
VWQ.
PWQ. Well, that
VW.
VWQ. Okay, so those two, I would not call those supplementary angles.
No. So wait, can you kind of explain to me why PWQ isn't a supplementary?
So you are right. No, it's a great question. Like honestly, sometimes you got to be like, I don't get where you're going there. So PWQ, he's like, if we had done when we started, PWQ was this right here. This is definitely 180 degrees. So people think supplementary, they think 180 degrees, but remember it has to be a pair of supplementary angles. Supplementary angles are two things that add up to 180. If I said I'm about to give you two things that add up to 180, and I handed you $180, that was a really weird statement, right? Because you just said, I'm going to give you two things. So there's not a second thing to go with that. So what we're looking there are two angles that would add up to 180 degrees. PWT could definitely be one of them, but then the rest of us are kind of forced to choose the second one. We had a lot of options. Once we choose the first one, we're kind of locked into the second one. Yes, sir. Help us out. Well, WP is just this, and WQ is just that. So actually, you're giving me the same thing that he gave me.
Why would that be?
Again, it's not about being 180. It's about two things that add up to 180. I need two things that add up to 180.
Those two things don't add up.
Well, when I do PWQ, that's already 180 all by itself. So adding anything onto it is going to be more than 180.
No, because he said PW and WQ.
Right, but those aren't even angles. Those are PW. Here's PW. Here's WQ. Those are just line segments. Yes, sir.
PWT and PWV.
PWT, that's what's drawn there, and PWV. Those two would work together because if you look together as a pair, they make 180 degrees. That was not the only combination you could have done. You could have done lots of them. Somebody want to give me a different pair? All right, so I'm going to erase this diagram here so I can show the other pair. So it'll be in the video. You can go back to it if you're like, wait, I didn't get that. Money, give me another one.
VWQ and TWQ.
VWQ and TWQ. Notice his are also a linear pair. They just happen to be on the other side. So I'm sorry, not PWQ. VWQ. That looks like a Y. And TWQ. All right, so there's actually even more than that, but let's not go through all of them. I think we get the hang of it. It's like two angles together that have to add up to 180 degrees. There's actually a whole bunch of combinations here, way more than it looks like, because we can mix and match some things. So let's talk about vertical angles. I'm going to erase those green lines again because I want to talk about the vertical angles. Yes, ma'am?
I think PWT and VWQ.
PWT, VWQ. Why did I put the exact same markings on both sides? I'm just going to separate these. These are my vertical angles. PWT and VWQ. Why did I put those markings in there? The same marking in each one?
Because they have the same angle.
They will always, vertical angles will always be congruent. I do that because we have to get in the habit of understanding that this is going to unlock a lot of information for us. How about another set of vertical angles? Colette?
WB and TW.
Angle PWV and angle TWQ. Question, I switched to two lines there. Why did I switch to two lines instead of just making those single lines as well?
Because those two are the same as the other ones with the one line.
Right, I needed to differentiate them. The one on the left and the one on the right, they match each other, But the one in the top and the one in the bottom, they match each other, but they don't match the other set. Like, you know what I mean? It's not like quadruplets here. There's two sets of twins going on, the left and the right, and the top and the bottom, like two sets of twins. The top matches bottom, left matches right, but it's not like everything is the same here.